Okay, based on the extensible hash table we introduced before, we plan to do the insertion into the hash table. So given the input extensible hash table as shown here, we plan to insert one more key and a pointer pair. The new key we plan to insert is 1110. We know right now the hash function only defined based on the first I digits, right? If we plan to insert one more key, 1110, we know by the first bit, according to the hash function, we can project this key to a bucket, this bucket, right? So by the first bit, according to the hash function, we know it should be projected to this bucket. In the bucket right now, we have only one entry be used up, right? And the second one is still blank. In other words, we can insert this 1110, its key, into a second entry. You can follow me, right? We insert it here, and we can also put one pointer after it, pointing to some data tuples, even though we didn't show it here. So right now it is okay because we have space for putting this new insert key. If besides this one we want to further insert another key, if we plan to further insert 1010, how can we do the insertion? The process is very similar. By the first bit, right? Because we know that right now the hash function is defined based on the first I bits. By the first bit, we know it should be projected to the second bucket, right? 1010, the first bit is 1. According to this hash function, 1 should be projected to the second bucket. And we can go over all the entries in this bucket. We find it right now are all used up. But we can temporarily put this 1010 into this bucket. We know right now the bucket exceeds the storage space, and we have to extend this bucket. We have to split it into 2 buckets instead. For the hash table we introduced before, right, we mentioned we can create some follow-up buckets or blocks after it. It's called the overflow blocks. However, here we don't want to do so. We plan to grow this bucket in a vertical way instead. How can we do the growth? We will grow this hash table by increasing the I. Right now I equals to 1. We increase it to 2 instead, right? If we grow this I equals to 2, in other words, we have to check the first 2 bits to differentiate them, right? And also put them into different buckets. So by following this idea, we can grow this I from 1 to 2. Right now we have I equals to 2 now. In other words, we have to check all the first 2 bits. Given 2 bits, we can project them to the corresponding buckets. In other words, by checking the first 2 bits, we have 4 different options: 0, 0, 0, 1, 1, 0, and 1, 1, right? There are different options we can have. So given 2 bits, we can project them to the buckets. Like for this example, 0, 0, we know according to this hash function, we have to project the key to the first bucket as shown here. But for 0, 1, this entry, if given a key with 0, 1, right now we don't have any key to match this entry, right? And we also don't need to create this bucket because we don't need to use it yet. And in the growth, we can just directly apply this pointer pointing to the first bucket as well. In other words, 0, 1, the hash function will also project it to the first bucket. We don't need to create one empty bucket right now, right, for 0, 1, because we don't need to use it. We can just project this 0, 1 to the first bucket as well. How about the remaining ones? 1, 0, we can project it to a new bucket because we split the original bucket into 2 instead. 1, 0 will be pointing to a new bucket. All the keys inside it, they all start with 1, 0, right? And for the keys starting with 1, 1, we can project it to a bucket with 1, 1, right? Right now we're going to use 1 entry inside it. The second one will be blank. In other words, we'll grow this I for the hash function. It can provide this hash function with more capacity. At the same time, we also grow these buckets Before we mentioned that for the bucket we have a tag, right, indicating how many bits are used in defining the bucket ID. So for the first bucket, we didn't grow it yet. In other words, the tag we have for it is still 1, right? We only check the first bit for defining the bucket. However, for the two new buckets, because we grow it by splitting the original bucket into 2 instead, we know if we only check the first bit, it's not enough to differentiate them, right? We have to grow it to 2 as well. Therefore, the text for the two new buckets will be 2, as shown here. And I hope you can follow me, right? So this is about the split of the buckets into some new ones. So besides this insertion, if we plan to further insert some more keys into the hash table, how can we do this? Let's assume we plan to further insert 0000 as well as 0101. How can we do the insertion? When we insert the first one, this is 0000 first. According to the hash function right now, we have to check the first 2 bits. We check 00, right? The first 2 bits. According to the hash function, we know we have to project this key to the first bucket, because this 00 will be projected to the first bucket, right? And we can put this 0000 inside this bucket. It's very safe right now, because this one still has a 1 empty space. We can put this 0000 here. If after this insertion we further insert this 0101 into the hash table, according to the hash function right now, the first 2 bits 01 will be pointed to the first bucket. Because right now we don't need to use this 01 bucket yet, right? We haven't created for the 01 yet. We'll point it to the first bucket, and we're going to insert 0101 inside it. We know now we have to grow it by splitting this 1, right, into 2 instead, because it exceeds the storage space for the buckets already. We have to split it. The splitting process is very similar to the previous one. We split it into 2, right? We store the keys with starting with 00 into the first bucket. We store the keys with starting with 01 into second bucket. We will have to change the pointers or the hash function, because right now we have 1 bucket for the 01 already, and we have to change the pointer to the corresponding bucket created for the 01. This part is the hash function, right? Besides these changes, we also need to change the tags for the buckets, because right now for both of these buckets we use 2 digits to differentiate them and define the buckets. We also grow them to 2 instead. Okay, so this is about the extensible buckets as well as the hash function and the hash tables. I hope you can follow me, right, for the extensible hash table. And you can also try these examples by yourself after class to do the insertion into the extensible hash tables. Okay, so let's say about the extended hash table, and we'll move to another new hash table in the following lectures.